This next unit is all about circles, and we're going to start off with looking at angles in circles. So we have a bunch of different types of angles within circles, and we're going to start with looking at central and inscribed angles. When we're looking at central and inscribed angles, we do need to remember that a circle has 360 degrees. Our central angle is the angle with the vertex at the center of our circle, and the two sides are radii. So if we look at our picture to the left here, B is that center, and then AB and BC, those two sides, are the radii. So angle ABC in this case would be our central angle. Like I said earlier, circle is 360 degrees, and then when we're looking at central angles, we can also talk about the measure of the arc that's formed. We'll look at arc length a little bit later on as well, but for this, with central angles specifically, it's equal to the central angle. So the measure of the arc is equal to our central angle. Again, looking at the picture to the left here, if I see arc AC, so we mark it with the arc above. If my central angle is 84, then AC is also 84. And then to find the major arc ADC, I just subtract 84 from 360 and say that it's 276 degrees. So a couple more examples like that. We're looking at number 1 here. We're going to start off with finding the measure of arc ST. I see that that central angle is 122 degrees, so that's what my arc is going to be. Looking at RS, I know that from R to T, so that entire arc there, is 180 degrees. It's half of my circle, so I can subtract 122 from 180 to get 58 degrees. Then to figure out SRT, that arc, we can add RS, and then we can add it to 180 degrees, which would be from R to T, and that gives us 238 degrees. We're going to look at a couple of more problems. So with number 2, we're looking first for the arc of JK. I see that that central angle is 21 degrees, so the measure of the arc is 21. Then the next question is looking for the angle of JNM. So if we look, JNM and then angle JNK form that supplementary angle 180 degrees. So we're going to subtract 21 from 180 to get 159. I'm looking for KL, that arc measure now. I know that JNM and KNL are vertical angles, so that means they're congruent. So KL is going to be 159 degrees as well. Looking now, we're going for arc JKM. So we're K to M, so KLM is 180 degrees, and then I'm adding it to that 21 for 201. And then the last arc measure for this problem is MKL. So we're going all the way around. The only part that's not included is ML, that little arc there. So I can take 360 and subtract 21 from it to get that measure of the arc is 339 degrees. Number 3, we're going to start off with angle UXV. So UXV is going to be this angle right here. In order to find that angle, I'm going to use the fact that I have vertical angles within my circle. They told me that the arc measure is SW is 72 degrees, so that means that SXW, that angle right there, is 72. And then angle UXV is the vertical angle to that, so that's going to be 72 degrees. Looking for the arc measure of ST, I am going to take 180, so W to U, and subtract my 87 and my 72, and I'll find that that measure is 21. Looking now at arc WV, I can add my measures for UT and ST, so 87 and 21 to get 108. Looking at T to W, that arc, I'll add 72 to 21 to find 93 degrees. And then the last one, TV W. So I'm going to add 3 different angles, my 87, my 72, and then my 108, and find that that arc measure is 267 degrees. Number 4, we'll do the same way, so I'm just going to show you the answer for that one there. I will point out, though, that we do have that right angle measure, so we'll be using that, and then a CHD and GHE are vertical angles, so we can use that with our 90 degrees as well. Central angles, we can do these problems with a little bit of algebra in it, so with our algebraic expressions. If we look at number 8, we see that they're asking us to find the value of x, and then using the value of x, we can find all of these different arc measures. Starting off with finding x, they gave me 2 algebraic expressions for my arc measure, and those angles are vertical angles. So I'm going to set 10x minus 22 equal to 8x plus 12, and I'm going to solve and find that x equals 17. Now that I know that x is 17, I can use that and find all of my missing arc measures. The first one that they're starting with is AD. So they gave me my algebraic expression for AD. I'm just going to plug 17 in for x, and then I can find that that is going to be 148 degrees. To find CD from there, the measure of arc CD, I can just subtract 148 from 180 and get 32 degrees. And then the last one that they want me to find is BD to C. So I can add my 148, I can add my 32, and then CD and AB are vertical angles, so their arc measures are also going to be congruent. So we'll add 32 again to get that BDC is 212. Number 9, for our algebraic expressions here, I can add them together and set it equal to 180. So JK and KL are half of my circle. When I solve, I find that x equals 9. Or I can find everything else based off of my x value. So starting with arc JK, I'm going to take 9 and plug that into my algebraic expression and find that it's 68 degrees. For MJ, I am going to subtract 68 from 180, and for LMK, I'm going to add 68 degrees twice and my 112 to get 248. Number 10 is the same process, so I'm going to show you all of that work and those answers. I do want to point out for number 10 that in order to figure out the value of x, we're adding 3 different expressions, and those 3 expressions equal 270. So a circle is 360, and they told me that I had one right angle here, so I took that away from my 360 and set all of my other expressions equal to 270. Those were central angles and the arc measures with them. Now we're going to switch gears to inscribed angles. So when I have an inscribed angle, that is when the vertex of my angle is on the circle, not in the center. Then instead of the 2 sides of my angle being radii, these sides are actually chords. So they go from one side of the circle to the other without passing through my center. Inscribed angles, we have the intercepted arc, and that's the arc that lies between the endpoints of our inscribed angle. So if we look at this side here, that would be arc AC. The measure of our inscribed angle is equal to half the measure of the intercepted arc. So if we look to the side here, we have our little formula that we can use. So angle ABC is half of whatever arc AC would be. We also have intercepting at the diameter. So when I have an inscribed angle that intercepts a diameter, then it forms a right angle. So angle BAC in this case is that 90 degrees. And then we have overlapping arcs. So this is the last kind of thing to look at within our inscribed angles before we do some problems. Overlapping arcs. If 2 inscribed angles intercept the same arc, then those angles are congruent. So if I look ABD and ACD are overlapping, they have the same arc. So they're going to be congruent, and the arc that they share is AD. So let's do a couple problems with all of that. Number 1, they gave me the arc, they gave me WY, and I want to find what that angle is. So in order to figure out that angle, I am going to do half of 62 and get 31 degrees as that inscribed angle. Number 2, they gave me my inscribed angle and I want to find that arc. So to go from my inscribed angle to the arc, I'm going to double it. Double 113 is 226 degrees. Number 3 is an example where I'm going through my diameter. So when I'm going through my diameter, if I'm looking at angle PQR, that means it's 90 degrees. It would also work if we didn't remember that because P to R is 180 and half of that gives us that 90. Or we're finding the arc of BC. So before we can find the arc of B to C, we actually need to figure out AC. That way we can subtract it from 180 degrees. They gave me my inscribed angle is 47 degrees, so I'm going to double that in order to find AC is 94. And then I can subtract 94 from 180 to find that BC is going to be 86 degrees. For number 5, I am trying to find the angle JKL. In order to find that angle, I need my arc JML. To do that, I'll take 53 and 65 away from 360, and then I'll cut that in half to find that the angle is 121 degrees. For number 6, we're going to find angle RST and angle RUT. That's where I have those overlapping arcs. So they both share arc RT, and I know that those two angles are going to be congruent. In order to figure out what my angles are, I first need to find the arc RT. I have all of the other arc measures around my circle, so I'm going to subtract those from 360 to find the measure of RT. And then to go from RT to my angle, I'm going to cut it in half. So each angle is going to be 41 degrees, and those are congruent angles. Just like central angles, we can incorporate a little bit of algebra into these problems. So number 7, we're looking to solve for x. The relationship between my angle and my arc is my angle is half of that arc. So when I set up my equation, it's going to be 8x minus 9, that angle equals half of the arc, which is 79. And then when I solve for x, I find that x is 11. Number 8, I'm solving for x again, so they gave me my angle is 67, and the arc they gave me as an algebraic expression. When I set that up, there are a couple of different ways, but the way I'm going to set this one up is do 67 equals 1/2 times the expression 4x plus 58. You could also automatically just double the 67 and then set it equal to your algebraic expression. When we solve, we find that x equals 19. For number 14, 15, and 16, we're using algebra as well. This time we have to actually mark our picture ourselves. So they gave me STU, that angle is 5x minus 16, and the arc SU is 12x minus 50, and I need to find what the measure of STU is. Starting off with finding my x, I am going to take the angle, and we can double our angle and set it equal to the arc, or you could do just the angle, so 5x minus 16 equals, and then on the other side you would have that 1/2 and then our expression. So you can do it either way, but we'll find that x equals 9 when we go through all of that work. We need to take x equals 9 and plug it back into our algebraic expression for our angle so that we can find that the measure of STU is 29 degrees. They gave me two algebraic expressions for my angles. These angles are overlapping with that arc AD, so I know that angle ABD and angle ACD are congruent. I'm going to set those expressions equal to each other in order to solve for my x. When I do that, I find that x equals 5. I'm going to take 5 and plug it into one of my angles. So in this case, I'm just going to use angle ABD. When I do that, I find that the measure of angle ABD is 56 degrees. So again, that means that ACD is also 56. When we do that, we find that the measure of AD is 112 because we're doubling it. So that's using our inscribed angles and our central angles when we're looking at measures in circles.